So as you've likely noticed, I've taken 7A and divided up into three sections, a supplement, and then as you saw previously with probability, the last part of 7A is odds. The three topics were very different, so I just wanted to break those up to be able to focus solely on specific topics. I'll start here in this first paragraph, actually explaining some of this information here. I was looking at an article on ESPN.com called Bracket of the Gods last year, and it was fit perfectly with what we're talking about here with odds. You know, you might even remember this. Warren Buffett made $1 billion bet that if a person could pick the perfect NCAA basketball bracket, he would give you $1 billion. But he kind of had the odds in his favor anyway. The odds of picking a perfect bracket with zero basketball knowledge whatsoever is 1 in 9.2 quintillion. So not very likely to happen. To maybe break this down even a little bit further for you, because that's an extremely large number. Let's take it down even a notch here. The odds of you dying in a vending machine accident are 1 in 112 million. So if you think about it, it's much more likely for you to be taken out by a Coke machine than it would be for you to pick a perfect bracket. But hopefully that's a nice little introduction here to these 1 in 9.2 quintillion and 1 in 112 million. Those are both examples of odds. Odds are very quick computations, and so for that reason, sometimes I'll see students figure out only one probability and then not get the full odds. So be sure that you take the time whenever you see us here calculating the odds. Be sure you take the time to figure out both probability that the event happens and the probability that the event doesn't happen, and then go to your ratio. So there are two types of odds. There's an odds against an event and odds in favor of an event. Odds in favor of an event is the probability the event happens divided by the probability the event doesn't happen. And you can think of that as well. If the event happens, it's a success. If it doesn't happen, then it's a failure. And then what's going to happen is that you're going to write success to failure. So odds are always going to be written in a ratio format. They will not be a fraction. What I would always recommend that you do is that, here you're calculating these probabilities. I would reduce those probabilities so that whenever you get here to the ratio format, it's already in reduced form. To me, it's second nature to reduce a fraction, but probably not second nature to reduce a ratio. Then the other type of odds is the odds against an event happening, and that would be the probability that the event doesn't happen divided by the probability the event does happen. And so that would be failure over success, and likewise the failure is coming first in your ratio, failure to success. A couple of things to note: that odds are always written in ratio form, not as fractions. They are part to part. So that means that your odds can be larger than 1. They don't have to, but they can be larger than 1. Like we saw in the previous section with our probabilities, they couldn't be greater than 1, but odds can. The type of odds being calculated tells you what comes first. So if it's the odds in favor, then the event happening comes first. If it's odds against, then the event not happening comes first. This is the important part, okay? Whenever you're calculating these odds from scratch, this is where I see people that if they get it wrong, they are forgetting to find both of these probabilities. From the top, always find the probability the event happens, and then find the probability that the event does not happen. It should be a nice check for yourself that those two probabilities added together should always add up to 1. I'll show you that in just a moment. You always then you want to express your ratio in the correct order, for or against. I'll show you. Like for, remember, means that the success is first. Against means that the failure is first. You're going to see. I'm going to show you these problems. This first problem the long way, and then you're going to see that there's a shortcut that can be taken here to simplify your calculations just a bit. So let's jump right in so you can sort of see all of this play out. So here in example 1, it says in her wallet, Anne has 14 bills, $7 bills, 2 5s, 4 10s, and a $20 bill. She passes a volunteer seeking donations from the Salvation Army. She decides, okay, I'm just going to select one bill at random. I'm going to donate it. So sample space, I just listed out the 1s, 5s, 10s, and the 20. I want to determine the odds in favor as well as against Anne selecting a $5 bill from her wallet. So if you want the if you want the odds that she would select a $5 bill, then I need the probability that that event is going to happen, the probability that she does select a $5 bill. I'm also going to need the probability that that event doesn't happen, that she doesn't select a $5 bill. So again, always find the probability that the event happens and that it doesn't happen. So the probability that she would select a $5 bill, there are 2 5s in her wallet. Out of the total 14 bills in the wallet, that can be reduced to 1/7. The event not happening, so she doesn't select a $5 bill, then that means there are 12 other bills in her wallet out of the 14, and then that can be reduced to 6/7. All right. A nice check for yourself. Make sure that these two probabilities, when added together, equal 1. And sure enough, 1/7 plus 6/7 would equal 7/7, which is obviously 7 divided by 7 would give you 1. So always make sure that the probability the event happens and that it doesn't happen, that they add up to 1. And that's, like I said, just a nice loose check for yourself. So now, if I want the odds in favor of her selecting a $5 bill, since I want odds in favor, then I want the success, her actually selecting a $5 bill on top, and then the failure on the bottom, her not selecting a $5 bill. So like I said, I'm going to show all my work here in this first part, and then I'm going to show you the shortcut. So probability of her selecting a $5 bill, we've already calculated that to be 1/7, divided by probability that's not a full $5 bill, that was 6/7. And so we definitely need to clean this up. You've got a fraction, you've got 2 fractions within a larger fraction here. I'm not sure how much you remember from your previous math classes, but when you divide fractions, you may have heard of copy, change, flip. You copy the top, change it to multiplication, and you flip the fraction on the bottom, so that'd be 7/6. Hopefully you also remember, well, hey, if you're diagonal, that they can be canceled out. So here, these 7s are diagonal. They cancel out. And so up top, you're left with 1 times 1, which is 1. On the bottom, 1 times 6, which is 6. That's now reduced. I now need to put that in my ratio form, 1/6. Here's the shortcut. Back from the top, once you had taken your probability of your 5 on top and your probability of your not a 5 on the bottom, once you were sitting right here, it is always going to be the case that those denominators, when you do your copy, change, flip, those denominators are always going to be the same, and they are always going to cancel out. So it should always be the case then. You can just cancel that out, and you could go immediately to, oh, that's 1/6, and then just get you right into your ratio form. Okay, so just know that you don't have to do this piece right here, and I'm not going to from here on out, because like I said, it's always a copy, change, flip. The denominators will always be the same, so they're always going to reduce. In part D, you want the odds against her selecting a $5 bill, so since you want odds against, then you want the failure on top, not a 5. And so that we know is 6/7 divided by the success, her selecting a 5, which was 1/7. I'll go ahead and do that shortcut. Those denominators are going to cancel out. That leaves me with 6/1, which gives me 6/1. When you're doing odds, you always need a number on the left and the right. So you don't reduce that and say, oh, that's just 6. You need a left and a right, because odds have a meaning, and we'll do that in just a moment. There was one other thing I wanted to point out. Oh, I know. In part C, whenever we had found the odds in favor of it being 1/6, I showed my work in part D here as far as odds against, putting the not on top and the success on the bottom. But if you're ever looking at the same event and you want to find the odds in favor, and you've already found that, and then you want to follow that up with the odds against, it is always going to be the reverse. So you technically don't even have to show that work either. Okay. And I said, okay, well, I said also that I'd point out, well, what's the meaning of this? Well, this means that if she were to draw from her wallet 7 times, and I'm getting that 7 by adding these two numbers together, 6 and 1 is 7, 1 and 6 is 7. So if she were to draw from her wallet 7 times, you would expect her to pick a $5 bill, the success of her picking a $5 bill 1 time, and 6 times would be not a $5 bill. Okay, so that's the meaning there. I put a couple of notes down here. When you're doing the odds, I'm just reiterating because this is what I always see people forget to do. Always calculate the probability the event happens as well as the event not happening. Those two probabilities, then reduce them if you have to, and they should always add up to 1. Okay? I'm going to flip it on over to the next page. I'm going to let you try example 2. I think that one's fairly straightforward. Let's look at example 3. I'm just going to do part A. A special 6-sided die has the following symbols on it. So a diamond, 3 hearts, and 2 clubs. It's rolled 1 time. Find the odds in favor of you rolling a diamond. So remember, I need the probability that this event happens, so the probability that I roll a diamond, and then I need the probability that it doesn't happen, so not a diamond. So looking at my die here, I can get a diamond 1 time out of, it's a 1, out of 6. Not a diamond then is going to happen 5 times out of 6. Lose check for myself, but I can see here these fractions can't be reduced, and if I add them together, 1 6 plus 5 6, sure enough, is 6 6, which is 1, so I'm doing okay there. Now, if I want odds in favor, then I want the success, the yes, to put on top, so that's going to be 1/6 divided by the failure on the bottom, 5/6. Like I talked about a minute ago, denominators are the same, they cancel out. That leaves me with 1/5, which would be 1 2 5. Final answer. Those are my odds, 1 and 5. Okay. Odds against, I'll let you try part B, but since it's odds against, then the failure is going to be on top, the not. Okay. Let's look at example 4. A little different there. A study of 175 airline flights in January 06 showed that 138 of them were on time. One of these flights is selected at random. Determine the odds against the flight arriving on time. So I want this odds, so I need probability first. I need the probability that it's on time, and then I need the probability that it is not on time. So the probability that it's on time, it told me in the problem that 138 of them arrived on time. So that would be 138 divided by the 175 flights that were observed. So then if you're not on time, there's still 175 flights, and of those, to figure out your top number then, if there's 175 of them total flights and 138 of them are on time, to figure out how many are not on time, I'm going to do 175 minus 138, which would leave you with 37. You can try to reduce those. They cannot be reduced. Since I want odds against, then I want the not to be on top. So the not is my 37 out of 175 divided by the success, the 138 out of 175. Like we've spoken about, those 175s cancel out, and so that's going to leave me with 37 to 138. Okay. Example 5 and example 6 are similar. Example 6 is the harder one, so I'm going to talk you through that one. In example 6, it says the probability of drawing a winning ticket in a local raffle is 0.06. What are the odds against you winning? So they're giving me the probability of me winning. So, probability that I win. But you'll notice here they give it to me as a decimal, 0.06. I want to keep in the same vein of, I want to get it back to a fraction. If you say that decimal out loud, of course we could say it as 0.06, but this is in the tenths, hundredths. Another way to say that is 6/100ths. You just said it then as a fraction, 6/100, which can be reduced to 3/50. So the probability of me winning would be 3 out of 50. Since I'm trying to find odds, I need the probability that I don't win. So the probability not winning. Well, if it's 3 out of 50 that I would win, then it's still going to be 50 on the bottom. If I've got 3 chances of winning out of 50, then I have 47 chances of not winning out of the 50, and that couldn't be reduced. Hopefully that makes sense to you. Again, I took that 0.06, changed it to a fraction. You could do it in your calculator. You could do 0.06 and then use your calculator buttons to change it to a fraction. Or like I said, if you said this number out loud, 0.06, it would be read as 600ths. So I said 6 over 100, and then I reduced it to 3 over 50. So if you've got 3 chances of winning out of the total 50, how many chances of not winning? 47 out of the total 50. Because remember, you need these two probabilities, 3 out of 50 and 47 out of 50, add together to give you 50 out of 50, which is 1. So now if I want odds against, then I want my not to be on top, 47 out of 50, divided by my yes on the bottom, 3 out of 50. Now we know those 50s cancel out. Final answer, 47 to 3. Okay. So what that means then is if I were to participate in this raffle blank number of times, you get that from adding these two together, 50 times, I would expect to win. The win is your success, that's your last number in this case, 3, and lose 47 times. Okay. I encourage you to go back and now look at example 5 before we move on to the next piece. So, now down here with calculating probability given the odds. This is essentially working backwards. That if you are given a specific probability, if you are given these odds, how can I get back to probability? And hopefully you can notice then, well, if you're given these odds, you can add these two numbers together. That's always going to give you your denominator. And then the problem would have told you whether it was odds against or odds for. And so if it's odds against, then the no is coming first. If it's odds for, then the yes is coming first. So with that said, let's look at a couple of these together. So in example 7, it says the odds of a stray dog, Sparky, having fleas is 7 to 2. What's the probability that Sparky has fleas? Well, if it says the odds for him having fleas, so it says odds 4, then that means that the 7 represents, that's your first number, that means the success that he does have fleas. So I'm going to put a yes there. 7 represents yes, he has fleas. 2 represents then no fleas. If I want the probability that Sparky has fleas, on the bottom, I add my two numbers here together, 9 total times, and then the probability that he does have fleas, then I want to choose my yes, and my yes number is my 7. So the probability he'd have fleas then would be 7 over 9. Let's look at number 8. Odds against. Odds against. So that means the first number in my odds then is going to be the no, and the second number then would be the yes, the failure to success. Odds against. The odds against Paul winning are 3 to 11. So in part A, it wants the probability that he does win. So again, I find the denominator by adding these two numbers together. So 3 plus 11 is 14. Probability that he wins, so the winning would be the yes, so I put 11 up top. Probability then that he doesn't win, denominator comes from adding those two numbers together, so 3 plus 11 is 14. Not winning then, the no, so 3 out of 14. And then I'll do one more with you since this one's just a larger number here. Odds of an American becoming a billionaire. So odds of it happening then, so that means the yes is coming first, the no is coming second. Calculate that an American is not a billionaire. So again, denominator is found by adding these two numbers together, so 790,000 plus 1, I'd have 790,001. And then on top, I don't want them to be a billionaire, so I'm choosing the no, 790,000 up top. Okay, and that'd be my final answer. As noted in Blackboard, there's not a lot of homework in the book that is well suited for this section, so that's why I created a supplement homework for this section. Highly recommend that you work through that before you attempt the quiz for this section, because I think that'll be very helpful to you. Okay.